So we're going to look at the review problems and the regular problems for week 4. And let's start with the review ones. So we have two differentiations. We wish to find the derivative of tangent of x squared. And we need to apply the chain rule. And the derivative of tangent is secant squared. So we will have secant squared of the inner function, which is x squared, times the derivative of the inner function, which means times 2x. The second differentiation has a double composite. So we have 5 to the secant of x squared. So let's think of our inner function as secant of x squared. And in that way, we take the derivative of 5 to the x is 5 to the x ln 5. So 5 to the inner function, secant of x squared times ln 5 times the derivative of secant of x squared. So we have to take the derivative of the inner function. Let's do this in our next step. So we will have 5 to the secant of x squared times ln 5 times, and now the derivative of secant is secant times tangent. So secant of x squared times tangent of x squared, and the inner function in this case is x squared, its derivative is 2x. So in other words, this derivative is equal to this, and that finishes the second differentiation. Let's go to our first review integral. So that's the integral of pi from pi over 6 to pi over 3 of secant x times tangent x dx. And we're looking for the antiderivative of secant x times tangent x, right? So we are looking for a function whose derivative is secant x times tangent x. We just mentioned it. That's the function secant. So this is going to give us secant of x from pi over 6 to pi over 3, which is secant of pi over 3 minus secant of pi over 6. And let's recall that secant is 1 over cosine. So this will be 1 over cosine of pi over 3 minus 1 over cosine of pi over 6. Now, what is cosine of pi over 3? So cosine of pi over 3 is 1/2. So this is 1 over 1/2 minus, and cosine of pi over 6 is square root of 3 over 2. So this will be 2 minus 2 over square root of 3. I mean, we could try to, I don't think it can be simplified much further. So I will leave it like that. Okay, I mean, I could rationalize the denominator. We don't do such things in college. Anyhow, let's go to the integral of tangent x. This is a classical integral. So think of tangent as sine over cosine and apply substitution. So u is equal to cosine x, and du will be minus sine x dx, which means that sine x dx, which is what we have, is minus du. So what I'm saying here is that sine x dx is minus du. So let me take that. Oops, what happened here? Let me get rid of this. So let's write the, again, a small technical glitch, and now we're back on track. And sine x dx is minus du, so allow me to take that negative sign in front. So we will have minus integral of 1 over u du. And that's, of course, negative ln of absolute value of u plus c, which will become negative ln of cosine x plus c. And now you can leave it like that, but it's quite traditional to take this negative sign. Whatever you have in front of an ln, you can put it as an exponent for the quantity inside the ln. So that will be ln of cosine x to the negative 1 plus c, which is the same thing as ln of 1 over cosine x plus c, which is the same thing as ln of absolute value of secant x plus c. And that's this antiderivative, this indefinite integral. Now, we're going to turn to the problems for this week. So for the first problem, we have a vector valued function, r of t is equal to 2 cosine t, 2 sine t, and 5t, the trajectory of this vector valued function, meaning the path that it traverses as t goes from negative infinity to infinity, or over any finite interval for that matter, is going to be a helix that is not so important for the problem. But the first thing that we want to do is find the velocity, the acceleration, and the speed for t is equals to pi over 4, this part A. So, so what is the velocity? So for the velocity, we need to take the first derivative of the position, and it's going to be minus 2 sine t, 2 cosine t, 5. We can plug in pi over 2, and this is going to give us minus 2, 0, 5. Okay, so that's the velocity vector for pi over 2. The acceleration is the derivative of the velocity. So this is going to be minus 2 cosine t, minus 2 sine t, 0. And if we plug in pi over 2, then this will give us minus, actually 0, and minus 2 and 0. And how about the speed? The speed is nothing else at pi over 2 than the magnitude of the velocity. That's in a motion. If you're in a car, that's what the speedometer shows, right? So it's going to be this, which means it's going to be square root of negative 2 squared plus 0 squared plus 5 squared. I'm just taking the magnitude of this vector, and this will be square root of 4 plus 25, that's square root of 29. That would be the speed. Okay, now it tells us to determine whether the angle between the velocity vector and the acceleration vector for t equals pi over 2 is right, acute, or obtuse. So that's part B. And for that, we should just take their dot product. So v of pi over 2 dot alpha of pi over 2, or A, I mean, you know, it's not important to call it alpha. I think most often we just call it A. But in any case, if we take the dot product of these two, we're going to just find 0. Okay, it's actually 3 zeros to add up. And that means that the angle is right. Okay, so the velocity and the acceleration are at a right angle. And the part C says to find the vector equation for the tangent at t equals pi over 2. So let's denote it by L of t. By definition, that's the position vector at pi over 2 plus t times the velocity vector. And because we have the direction of the velocity at that point. And r of p over 2, just plug in pi over 2 into r, and you will find 2 cosine of pi over 2, so that's 0. 2 sine of pi over 2, that's 2. And 5 times pi over 2 plus t times the velocity vector that we found in part A, which is negative 2, 0, 5. You can leave it like this, or you can write it as negative 2t, 2, and 5 pi over 2 plus 5t. So that's the tangent line. So interestingly enough, if you think of this as a motion, if the vector valued function as representing a motion, at pi over 2, if all forces cease to exist, then the moving object would just move along the tangent line, which is what we just found. So we found the vector equation or a vector equation for that tangent line. That completes problem 1. Let's go to problem 2, where we have a moving object whose velocity vector is given by 3t squared cosine t and 2 sine t. This is if you want to think about what in the world that could be, then by combining these two components, you get a sort of an ellipse. If you are on a plane, that of course would have been on the YZ plane, and then this 3t squared pretty much gives you a motion parallel to the x-axis. So you have a sort of elliptical helix that moves parallel to the x-axis. Again, it's not important to know what this motion looks like, but it's kind of interesting. And what is also given is that the position vector at time 0 is equal to 1, 1, 2. Remember that when we say position vector, by definition, we mean that it originates at 0, 0, 0, which means that if you forget about the vector part and you consider the point that is the terminal point of the vector, and you connect all those points, and you get your motion. That's the idea for vector valued functions and their trajectories. And here, what we're going to find, what the problem is asking us to find, is R of t, meaning v of t is, of course, the derivative of R of t. So what we need to do is take the integral, and let's take the indefinite integral, and we will need to use the initial condition, which is the position at 0. So we want to find the integral of 3t squared cosine t 2 sine t dt, and that is going to be what? We need to integrate in each of the components. So we're going to get t cubed here. We're going to get sine t, that's the n antiderivative for cosine t, and an antiderivative for 2 sine t is negative 2 cosine t. And now, normally you would have put a C1, C2, C3. What I can do is put one vector C, which needs to be determined in terms of the, or by means of the initial condition. So R of 0, on the one hand, is known to be 1, 1, 2. And on the other hand, if we plug in 0 in what we just found, we'll get 0 cubed, which is 0, sine of 0, which is also 0, and minus 2 cosine of 0, which is minus 2 plus c. Right? I hope you see where we're going with this. The idea is that this is the same as that, and that will mean that c is equal to simply 1, 1, 4. Okay, because we take 0, 0, negative 2 to the other side, it becomes 1, 1, 4. So finally, we can give the position function for our motion to be t cubed plus 1 sine t plus 1 and negative 2 cosine t plus 4. This is because we added the vector c, which was found to be 1, 1, 4. And that's it. That completes our set of problems for this week. Thanks for watching.